Okay. So under the Stirling numbers, so as we know, this is our factorial polynomial way of factorial polynomial. So this can be written in the standard form of Stirling point. Okay. So okay. So it will be written as S1 n of k plus S2. Let's say S2 n of k squared up to, it will be end on Sn of n of k of n, which is also can be written as in a summation way, S to the power I of n k I. Okay, I can be 1 up to anything. Okay, so they didn't put. Okay, so this S and N being the Stirling numbers, this kind of numbers we called as a Stirling numbers. Okay, let's see one example, so it will be very easy to understand. Okay. Okay, let me. So let's consider this example. So K3 like that, K3, okay, using the Stirling number system, S1 3 of K plus S2 3 of K2 plus S3 3 of K cube. So you have to go up to this point, isn't it? From our equation of Stirling system of first order, okay, first kind. So this is the, so you have to go up to, if it is n, you have to go up to n, okay. So in that sense, we already know our, k cube is equal to, what is that? Factorial way. Yk is equal to k cube. What is that? K. There's a definition. See the definition of factorial polynomial. If it is k n, we have k into k minus 1 up to, goes up to k minus, up to n minus 1 point. Okay. So that has written as k minus n plus n. So if it is here, we have k3, isn't it? So you can write in a bracket or k3. You have to go on up to where? 1 less than that. So k minus 2. So if you multiply this one, can you multiply? I already did know. This will be k cube minus 3k square plus 2k. Is that correct? So this is our factorial polynomial, which we are equating to our Stirling numbers. Okay. So in that sense, they are asking you to find the Stirling numbers. Okay. So what is our first number of S13? S13, you have to equate up to the kth one. See the differences. Okay. You have to be very carefully, when you are studying, you have to be very careful. So don't, interchange. Don't confuse the thing. See, this is starting Kn starting from K. First one we called as a S1n. Okay. So the power is 1 here. Here S1. Okay. Similarly, S2n K power 2. Up to it goes. Up to Snn Kn. But in the factorial polynomial, we use k minus 1 up to like that. K minus n plus 1. So n plus 1 terms. Okay. So when you are writing, you may write the k to the power n terms first. Okay. For example, if it is k3, we write like this, no? K3 minus 3k2 plus 2k. Okay. If you write and if you equate, you will be wrong. So first of all, you have to write the k term first, this one, 2k. The next term like this. There may be some terms not be available. Let's say, so, in sometime they may not have, anyway it will be have. Okay, here no problem. Okay, so you have to equate this one into our S1 3k, S2 3k, S2 and S3 k3. Then only you have to find the Stirling numbers S1 3, which is equal to this 2. Okay, that's what 2. So equate the coefficients. This second one, see here minus 3. So you have to put the minus 3. Okay. Similarly, S3 you have to put the 1. Okay. So this will be the example. So write down carefully. Okay. So that is the example for the Sterling number of the first kind. Okay. Similarly, they have written some kind of recursion formula for this. Okay, this is for the Sterling number. So just, you don't need that anyway. Okay. So you can analyze what it is. Okay, regression formula Si n plus 1 can be written as Si minus 1 n minus n times Si n. Okay. So using this one, you can write k n plus 1 will be this one. So you can derive this one. Okay. So anyway, we don't need that one for now. Okay. So these are extra things. So in some special cases, we have S1 n plus 1. So where you have to substitute I is equal to 1. So it will be minus n sin because 1 minus 1 will be 0 now. S not n. It will be 0. Okay. So in that case, it will be gone 0. So minus n sin only coming. So if you wanted to put for I is, this is I is equal to 1. If I is equal to n plus 1, what you'll get? So here n plus 1, n plus 1. So if you put n plus 1 minus 1, then it will be n. Okay, this term will be s and n. And here, this will be n plus 1. Because we in this Sterling of first kind, you see it's starting s1n, it's ending snn. Therefore, s naught n will be 0. Sn plus 1 of n also 0. So that's what those, if you substitute that terms at 0, you will end up this one. Okay. So from this, they have analyzed this one because they have put here n plus 1. If it is n plus 1, you have to substitute here n plus 1. Okay. So if you substitute, you'll get this one. Okay. Anyway, we're not going to use that one. So you go through it and find out and understand it. Okay. So let me finish with this quickly. We have 2 minutes only, so I'll go quickly. Okay. So this is a Sterling numbers of second kind. Okay. The same idea, Kn. Here we have to put K1, K2, like that. Only these are the difference. Okay. So here you have to put K to the power I. Okay. This SIN are being Sterling numbers again, but it is a second kind. Okay. So let's do some example and finish our lecture. Just write down the notes if you want. I will send anyway. Okay. So let's do the example. Okay. In this, for the second kind, okay, let's see. K3 will be equal to, so 2K1. Okay. So K3 is what? K times K minus 1 times K minus 2. Okay. So there you have to put this 1 wherever it, after that one, you will have this one, no? 2K minus 3K2 plus K3. So only thing is you have to put it in the bracket. Okay. This one. So this is equal to our Sterling second kind K1. So S13 will be 2. Yeah, this one. Yeah. Okay. This one also minus 3. Okay. Oh, if it is so, let's say this is plus 3. So this will be the answer. Okay. So S13 is 1, S2 is 3 and 2. So the recursion formula, this one, and the special case is I is equal to, see whether it is 1 and I is equal to n plus 1, something like that. So you will have, we don't have n plus 1, therefore they have put only for I is equal to 1. So this will be like this, and recursion formula will be this. Okay, check the recursion formula also. Okay, so I will do that example in next class because our meeting gonna finish now. Okay. If it is finished, we end. Okay. So just yeah. If you want, you can write the